And so we're back to our 5 Newton weight. We're back to our spring that extends with a spring constant of 50 newtons per meter. You'll notice that something is missing here. It was there before, making everything wrong. Maybe we'll blot that out in YouTube. So this is the theoretical situation where we raise the mass past the equilibrium point, and we can't do this with this spring. It's just not fancy enough. But we actually push it up, and if this was like a nice industrial spring, we'd push it up, and the spring would push down, and gravity will pull down, and when we let it go, this thing's really going to take off. So we're going to get a good acceleration out of it because the spring is providing a downwards force, and gravity is providing a downwards force. We want to find out what that acceleration is going to be. So we're going to start out with a free body diagram. And you'll notice that our weight is conveniently expressed in newtons, which of course is going to be a problem when we go on to when we move on to the next stage, which is going to be trying to find the mass, because we're going to have to do the F equals ma. Okay, so as well, the spring is going to be providing some sort of extension force downwards. And so we have two forces. Both of them are acting downwards because we've picked the mass up. And we want to find out what that second one is. And of course, force of extension is equal to negative k times x. And k in this case is negative 50 newtons per meter. And x is 0.1 meters. And so Fx is 5 newtons downwards. And so the total force downwards is actually going to be 10 newtons. So we have 10 newtons down. We also know from a certain law that the sum of the forces is equal to the mass times the acceleration. So negative 10 newtons is equal to the mass, and I can do this. I can. Who's making this so chalky? I want to know that. So a 5 Newton weight, ooh, that should be about a half a kilogram, right? Haha, it is a 0.51 kilogram mass. And we want to find the acceleration, so it's just a matter of rearranging this. And so now I'm just going to divide 10 by 0.51. There we go. So this thing is going to take off twice as fast as gravity. And as you can see, it was quite terrifying when I did let it go. So the prophecy has been fulfilled.